Computers store integers and real numbers differently. The Python data type names are int for integers and float for real numbers. There are a couple reasons why different types are used. One is it does not make sense to store fractional values for some things. For example, the number of quarters in your pocket should be an integer. The second is to allow a compact representation of a wide range of real numbers. A format similar to scientific notation is used. For example, with 6.02 times 10 to the 23rd, 6.02 is the mantissa and 23 is the exponent. The term float is short for floating point representation. As with scientific notation, the decimal point moves or floats based on the exponent. The mantissa for a Python float has about 15 significant digits. Python stores integer values exactly. Recent versions of Python automatically use extra memory for large integers, so you can perform calculations with very large integers without any extra work on your part. It just requires more of the computer's memory and takes more time. Most real numbers cannot be stored exactly the way the computers store floating point numbers. For example, 0.1 is not stored exactly using the standard format known as IEEE 754 that all modern computers use for representing floating point numbers. We will not learn the details of this format in this course, but for now realize that all non-integer values should not be assumed to be completely accurate. We will look at another memory picture to help you visualize what this difference means, and that it is actually storing different data depending on the type. Internally, everything the computer stores is represented using only ones and zeros. When we assign a variable in Python, it determines what type the expression on the right-hand side of the assignment statement evaluates to, and creates an object of that type. The object stores the type information, along with the actual data, and additional information that is the reference count that keeps track of how many different variables refer to that object. For example, when we write x equals 3, here is a picture of the memory. It creates an object that has the type information that I've written here as int, but what is actually stored is a bunch of ones and zeros that Python knows corresponds to the int data type. The actual data that is stored for the integer 3 is a bunch of zeros followed by 2 ones at the end. Depending on the computer, there may be a total of either 32 or 64 ones and zeros there. And then since there is only one name, the variable x referring to it, the reference count is 1. When we write y equals 3.0, this creates a floating point value. In the picture here, I've written the type as float, but again, a bunch of zeros and ones are used to indicate the float type. The data for the float 3.0 is completely different from the data for the integer 3. It is a 0 followed by a 1, followed by 10 zeros, followed by a 1, and then followed by zeros for a total of 64 ones and zeros. And the reference count for it is also 1 since only the variable y refers to it. When we write z equals y, z now refers to the same floating point number that the y does. This causes the reference count for the number 3.0 to go to 2. Fortunately for us in this course, we do not need to worry about these internal representations. All we need to know is that integers and floats are two different data types. Floats may not be exact, that some of the operations work differently depending on the type, and what happens when an expression uses a mixture of integers and floats. This slide shows the common mathematical operators in Python. Addition, subtraction, multiplication, and division work as you should expect. The asterisk is the operator for multiplication, and the / is the operator for floating point division. The result of a floating point division operator is always a floating point result in Python. Two asterisks are the exponentiation operator. Two / together are the integer division operator. Think of it as performing regular division, but ignoring the fractional part of the result. The % is the operator for producing the remainder when two numbers are divided. For example, 11% 4 is 3, because 11 divided by 4 is 2, with a remainder of 3. 12% 4 is 0, because 12 divided by 4 is 3, with a remainder of 0. Let's look at a couple examples to help you understand how to calculate the results for integer division and the remainder. Perform long division, as you probably learned in elementary school. We start by finding the largest number that we can multiply 4 by and have it be less than 11, which is 2. Then we perform that multiplication and write it down, and then subtract and get 3. And now there's no number that we can multiply 4 by and have it be less than 3. So we write down the remainder as 3. So 11% 4 is 2, 11% 4 is 3. As we can see from the example here, there's the quotient and there's the remainder. If we're doing 4 divided by 11, or 4% 11, we would write it this way. And when we perform the long division, we put 0 there, multiply 0 times 11, put 0 there, subtract and get 4. And now there's no positive number we can multiply 11 by and have it be less than 4, so we write down remainder 4. That allows us to see that 4 divided by 11 is 0, and 4% 11 is 4. Whenever the first or left operand is smaller than the second or right operand, the result of integer division is 0, and the remainder is the first or left operand. Python also has some built-in mathematical functions. As we noticed before with input and eval, parentheses are placed after the name of the function, and the operands, also known as the parameters, that we want to send to the function are placed inside the parentheses. ABS is the absolute value function. The absolute value of 3 is 3, the absolute value of negative 3 is 3, the absolute value of negative 3.5 is 3.5. So notice that the type that we send to the absolute value affects the result. If you send it an int, you get back an int, and if you send it a float, you get back a float. The round function rounds values as you would expect. 0.5 and above rounds to the next number, while below 0.5 rounds down. So if we round 3.5, we get 4. If we round 4.1, we get 4. You can also pass a second parameter to the round function, indicating at which decimal point to round. So if we pass 1 as the second parameter, the result will have one decimal value and be rounded based on the value of the second decimal value. So 3.57 rounded to one decimal point is 3.6. Because floating point numbers are not stored exactly, you may get some surprises. Round of 3.55 to one decimal point is 3.5, because 3.55 is not stored exactly and is stored as a number just less than 3.55, such as 3.54999. The precedence order in Python matches what you most likely learned in a math course. Parentheses have the highest precedence, then exponentiation, multiplication, division, and the remainder are at the next level precedence, and finally addition and subtraction are at the lowest level precedence. For operands with the same precedence, the calculations are performed left to right. In this expression here, division and multiplication have the same precedence, so we do the division first and then the multiplication. The first step, we do 13 divided by 3 and get 4. Then we multiply that result, 4 times 5, and get 20. Then we'd add 2 and 20 to get 22. And finally we subtract 6 to get 16. Mixed type expressions are expressions with both ints and floats. Let's step through this example here as if we were the computer executing it. When we said I equal to 4, I will be an int, and then j equals 2, j is an int. And then in this expression here, because both I and j are ints, the sum of two ints is an int, so k will be an int. Now we have x as a float, and now because we're adding an int and a float, the result of y will be a float, so it's 6.0. And then we take i's value, which is 4, and divide it by j, which is 2. This is floating point division, so we get 2.0, so z will be a float. And then here with integer division, because both I and j are ints, and this is the integer division operation, w will be the integer 2. As soon as the result of an operation between two operands is a float, the result is a float. So in this example here, the first thing we would do would be 6 divided by 2 because of the precedence operation. That's floating point division and will give us 3.0. And then we add 2 plus 3.0 and we get 5.0, so b will be a float. Not all programming languages have separate division operators as Python does with the single slash and the double slash. Some languages decide whether to do integer division or floating point division based on the types of the operands. For example, in many languages, 3 divided by 2 would be 1, since both 3 and 2 are integers, so it does integer division. But 3 divided by 2.0 would be 1.5, since one of the operands is a float. Because of this, I recommend you get into the habit of adding the decimal point if you want floating point division. So for example, always write 3.0 divided by 2.0 if you want floating point division.